Today on How It's Made. Barber chairs. Sewage pumps. Bimini boat tops. And diesel filters. The reclining barber chair was invented in America in 1878. At the time, it was a grooming breakthrough. With a chair that leaned back and moved forward, the barber could shave the customer with greater precision. And when wielding a straight-edged razor, precision is definitely a good thing. The barber chair is the original easy chair. Just sit back and enjoy the recline. The client doesn't need to position himself for a shave. The chair does all the moving. It even lifts and swivels. Production starts with the base of the chair. An employee places a flat, round piece of steel in a two-part die. The die comes together and applies pressure to take the steel from flat to domed. The domed chair base then spins as an abrasive wheel etches a brushed finish onto the surface. Next, the worker tucks the end of a strip of steel between rollers and turns them to curl the steel into a sleeve for the hydraulic chairlift. He slides a piece of plastic into grooves on the ends to close the steel sleeve. Then he slides it onto the chair lift pump. He places a large trim ring on the end of the pump and sets the domed chair base on top. Screws secure the base and chairlift assembly. With the assembly now right side up, he attaches a U-shaped foot pedal to the pump. Production then moves to the construction of the actual seat. The worker glues several sheets of Russian birch and staples them together. She continues to layer until the birch is nearly an inch thick. The last layer is thick plywood. It's been cut to accommodate a steel frame. She glues and staples the plywood to the layered birch. Then it's into a press for the chair seat, back, and arms. It bends the parts to a gentle curvature that will make the chair more comfortable to sit in. With a hot stamp, the worker brands the company name and logo into vinyl upholstery. He places the wood chair back into a bed of cushy foam. He pulls the edges of the foam tightly to the wood and staples it. He trims the excess. He covers the chair back with the pre-sewn vinyl upholstery, and it's a snug fit. Next, he gets a hand from a pneumatic device. It holds the chair part in place as he staples the upholstery to it. He trims the vinyl for a clean edge. He checks the fit, and once satisfied, he moves on to the chair arms. He locks an arm in a clamp and installs the chrome end piece. The chrome resists wear better than vinyl does, important on this gripping part. The crew attaches the steel chair frame to the underside of the upholstered seat. They screw the arms onto the frame. They install the pneumatic mechanism that makes the chair recline. They screw the upholstered chair back to the steel frame and link the recliner mechanism to it. They test the recline and incline functions. The footrest is next. They then pump up the lift shaft and transfer the upholstered chair to it. They close the back of the chair with an upholstered panel. And finally, they give the customer a place to rest his head. With the headrest installed, this barber chair is ready for customers. Time spent reclining in it will no doubt leave the client looking and feeling refreshed. A sewage pump is part of an underground operation to dispose of human waste. It is essential equipment when sewage must be pumped to a septic system or sewer line at a higher underground location. Working below the surface, sewage pumps take care of unpleasant business. When it comes to sewage, people understandably prefer to flush and forget. The sewage pump helps make that possible. It is the #1 way to move waste. When the sewage reaches a certain level upon discharge, the pump's floating sensor activates a switch to start pumping. Then it's on its way to a septic system or sewer line, ensuring that sewage receives the necessary treatment. They make the sewage pump housing from a rugged cast iron. A chain conveyor takes the housing parts for a rinse and an application of a chemical that slightly etches the surface in preparation for finishing. The journey continues through a big dryer that removes residual moisture. The parts now head into the spray booth for a finish that will protect the surface. The conveyor delivers a negative charge to the parts, causing the positively charged powder finish to gravitate to them. It completely coats the parts, and they travel through an oven to bake on the powder finish. Next, workers move the pump housing units across to a spinning abrasive disc. This grinds the edges flat to allow for a tight seal to other parts. Here's the housing before grinding, and here it is after. He places a gauge under the part in several places to ensure that it's completely even. Next, a tool machines the part of the housing that holds the stator, the stationary part of the motor. It carves the opening so that the stator will fit to it, and also a line next to the motor housing. Using a drill press, a worker cuts a thread into another part of the pump. This will allow it to connect to a discharge pipe. The parts are now ready for assembly. A worker presses the carbon half of a seal for the rotor shaft into place. He lubricates the rotor shaft and inserts it into the pump housing. A blast of compressed air removes any contaminants. And he installs the ceramic half of the rotor shaft seal. Next, he screws the impeller to the rotor shaft. The impeller will move sewage from the pumping chamber to the discharge pipe. He installs an O-ring around the opening to the motor. He inserts the stator and screws it into place. He connects lead wires to terminals in the motor housing and sets it in place. He runs the power cord through the motor housing and tightens a seal around the cord. He attaches a metal guard to give the pump float adequate clearance, then seals the motor housing and wires the pump switch. He screws the switch case to the housing. A worker plugs in the pump to test for any shorts in the electrical components. The pump passes all the tests. It's ready for the float that actuates the pump switch. A piece has been cut out of this pump to give us an inside look at the sewage pump and its operation. As wastewater rises, so does the float, and it activates the switch to turn on the pump. When the sewage subsides, the float lowers and switches off the pump. Next, the pump takes the plunge in a test tank to ensure that it can handle the pressure and that it meets all the performance standards. Once the computer gives the sewage pump the green light, it's on its way to a septic system near you. Built for a life of effluence, this sewage pump is now ready to go with the flow. There are unofficial claims that Bimini boat tops were named for the sun-drenched Bimini Islands of the Bahamas. The open-sided canvas tops are usually retractable, and beginning in the early 60s, were developed to offer boaters protection from the sun. Out on the open water, Bimini boat tops provide shelter from the rain and shade in the sun. Their durable and versatile materials withstand rugged sea breezes and intense UV rays, while providing ample headroom for boaters. A worker measures a piece of anodized aluminum tubing for the exact leg height needed for each custom-made Bimini boat top. Then, he cuts the tubing to the dimension needed for each boat. They use aluminum and stainless steel because they don't rust. The worker begins bending the frame of the boat top. The eventual roof support is on the floor, while he holds the leg height in his hand. He must be careful to not overbend. The final angle is about 88 degrees. The worker crowns the tubing, a process that puts a rise in the center of the roof and pulls the legs inward. Each Bimini boat top is made of 3 bows of different heights. The front is shorter than the back, while the center is usually about 40% of the back leg height. Workers now assemble the bows. They attach eye ends and jaw slides to form rudimentary hinges. They now unfold the assembled tubing using the precise measurements of a customer's boat. They simulate the final shape of the boat top by using tape to spread the bows to exact widths. Once the bows have been spread and the distance is measured, they can see the shape of the final boat top. All that's left is installing the roof itself. The roof is made of acrylic canvas that is both water and fade resistant, and there are plenty of colors to choose from. The patterning process begins. Once the roof is cut, a worker stitches the roof panels. Workers spread the cut panels over the bow setup to finalize the roof dimensions. The canvas fabric is clamped to the bow setup as a worker marks the edges on the outside of the fabric. The roof is made in panels. It usually takes 2 or more panels to complete a roof, depending on the size of the boat. Once excess material has been trimmed off, the worker begins stitching. She turns the outer edge of the roof and uses a straight stitch. She works on the sides of the canvas roof before the ends. The worker now patterns the listing, which is a pocket through which the bow will be inserted. Here's what the listing's raw pattern looks like once measured and cut. She places the finished listing on top of the panel and stitches it to the end of the roof panel. The stitching process is key to the durability of the boat top. She turns the roof over so the listing is backwards. It's actually sewn on inside out and then turned over. She stitches the entire length of the listing closed. Then the company's identification tag. Workers now insert the pieces of tubing into the listings of the canvas roof. First, they push the rear bow all the way through. Once the rear bow is in place, they prepare to insert the center and front bow of the boat top. They unfurl the remainder of the roof and position the center bow on the center listing. Gradually, they slide the tubing all the way through the center listing. With the front bow inserted, the Bimini boat top is almost complete. An employee inspects the boat top for any defects. Once installed, the Bimini boat top can either be tucked away in its boot or opened up and held in place by front straps. For the life of your boat, a well-maintained Bimini boat top has it covered. Running an engine on diesel fuel is efficient, but it emits smelly black exhaust, soot, leftover carbon that didn't burn off in the combustion process. To prevent exhaust emissions from polluting the air, diesel engines and diesel-powered generators need powerful filters. This self-cleaning diesel filter traps engine exhaust soot and burns it off by heating the filter elements. This effectively completes the combustion process. At the core of those filter elements are heating strips made of steel fiber, which is like dense steel wool. But the steel is a special mix of alloys resistant to high temperatures and corrosion. Each heating strip goes into a machine, which repeatedly folds it up, then down, pleating it like an accordion. The thick steel fibers are what trap the soot particles as the engine exhaust flows through. An electrical current heats these conductive fibers, burning off the soot regardless of engine exhaust temperatures. Using nickel crimps, workers connect, depending on the filter size, up to 7 pleated strips per filter element. They press the crimps securely into the steel fiber with a press. They attach a different type of crimp at the far ends. This type has a tab with 3 holes for the electrical connections. Next, they bend the assembled strips into a circle and place them inside a perforated steel housing. A temporary cardboard spacer creates a gap between strips and housing to insulate against short circuits. The electrical connection tabs on the ends fit through slots at the front. An insulating block made of mica, a non-conductive mineral, goes behind the tabs, followed by steel fiber spacers. All this sets up a clear and strong conductive path from the power source to the strips. They fasten the insulating block to the housing. Then, using tweezers, they place a mica spacer in between each pleat. This prevents the pleats from touching each other and causing a short circuit as the electrical current passes through the strips. They place a spacing stick inside each pleat. This is just temporary to size the pleat's width uniformly until they're cemented permanently in position. To do that, workers pour ceramic cement into a circular bottom plate made of perforated steel. The perforations ensure better bonding. They spread the cement evenly across the plate. Then, position a stainless steel tube in the center to connect this plate to an identical plate on top. They carefully place the strips into the cement and position the top plate. Then add a weight to hold it down while it goes into an oven at 85 degrees to cure the cement. "45 minutes later, they take it out of the oven and remove the top plate. They also remove the spacing sticks and cardboard spacer, which are no longer required because the spacing is now permanently set in cement. They repeat the cementing process with the top plate. After a final 4 hours in the curing oven, the electrically heated filter element, this diesel filter's key component, is completed, and the main assembly can begin. The larger the filter, the more filter elements it contains in its stainless steel housing. For this mid-size model, technicians stack 4 sets of 6 elements. Then connect electrical cables to the tab holes of each one. Next, technicians install a flow control valve for each stack. When activated, the valve reduces exhaust flow to that stack, enabling the system to automatically clean elements by electrically heating the strip. An internal computer manages the cleaning cycles. It uses sensors that detect soot accumulation in the elements, isolating and cleaning one or multiple elements at a time. On the front, techs mount the inlet flange, through which the dirty diesel exhaust enters the filter. On top, the outlet flange, through which that exhaust exits soot-free. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.